check. Let's see. There we go. Looks like I've got sound. Sorry about that, folks. Now we got sound. Excellent. Okay, so yesterday we were creating the drones, flying underneath. We were making the portals drop the meteors just as the drones would go underneath them. And we ran into a couple problems. Let me show you I had spent just a few moments looking at it afterwards and got to a fix. Essentially, there were two problems. If you look at this line of code versus this line of code right here, we were taking our velocity, multiplying it by seconds to crossover. That was going to give us an answer in meters, but we were adding that to our y, which was a unit of pixels. So we had to call physics.meters to pixels there to add those two together. So that was one of the pieces. Another one is just at the end of the show, we had realized that our numbers were too big. So I was like, well, maybe I've got the time wrong. Let's take off the the millisecond conversion here. That was the times 1000, and I added that back in. Those were the main two pieces there. So really the essence of what we were doing was right. Over here, there was another minor problem in that in QMeteor, I was checking to see if it was already in, and if it was, I was getting out. And now what I'm doing instead, if it's already in, then I'm going to just remove the existing one and break out of this loop and then come down here and add a new one back in again. So what this is allowing me to do is get a more precise meteor to throw if we haven't thrown it yet. Okay, let me demonstrate what what this looks like here. We're going to come in and let's do our test sample 4. And there it is right above me. The portal is up. And now if we launch the drone and come over to the right, as I fly underneath it, it should drop a meteor so that I catch it just as I come by. There it is right there. It also drops a ton of other meteors right afterwards as well. Let me know in the chat room if that sound on those other meteor drops is too loud, if I need to drop that. Yeah, meteors from another dimension, says Will. So we need to make sure those aren't dropping. And the way I propose to do that is if we've already dropped one, when we drop it, I want to somehow mark who it's for and then check to see if I've already got a meteor for that guy that we've already dropped. And if we do, then I want to not drop another one. So that's kind of what I want to do. The other thing that I want to do before that actually is this. One of the, in the code I've got, in fact, let's check this code in right here. So we'll say start of episode, what are we on here? We're on 55, I think, is what it looks like. And it looks like the description for this is wrong, though, based on what I'm seeing over here. I thought I updated the subscription. The description looks like I did not. Let me just do that. It's part 3. Update that. That should be updated now. Start of episode 55. Let's stage all that stuff and commit it. And let's add a new tag. This is going to be episode 55 begin. Push that up there. Add it. Let's bring up GitHub. Bring it over here. Do refresh. Should see episode 55 begin. There it is right there. I'm going to copy this, paste this in the chat room. Well, then it says, don't you already have that with the meteor to drop? Just only remove it once. The meteor is caught or exploded. No, the answer is no, we don't have that. We need to take care of a couple things here. One is we have a queue of meteors we're about to drop. We've got that essentially taken care of. That's updating itself. So that's accounting for the first one that hits. The other aspect of this, though, is once a meteor has dropped and your drone is still approaching, we don't want to keep trying to throw things at it. And that's kind of the second piece. There's a third piece that I want to address immediately, which is, I'll show it to you in the code. It occurred to me. Let's see if we can find that, the code that has occurred to me. It has to do with the drop time, the future drop time. This is it right here. So we're queuing the meteor at some future drop time, the future time where it's going to cross over minus the amount of time it takes to fall. And then once it's in there, then we check to see where is its start time relative to now. And if it's less than now, we drop it. In other words, if the time has passed, we drop it. The piece we're not checking here is we need to check to see if our drop time is already in the past, which could happen. If I'm very, very close and I have a long distance, well, I take now minus the long distance. It's already in the past. I add it to the queue and it's going to drop it immediately. So what I want to do here is I want to come in and I want to take this code right here. I want to create a new number that's going to be our, we're going to say our future drop time, like that. And it's going to be equal to this. And what I expect to happen with this check, hold on right here. If future drop time is greater than now, then we're going to execute this line of code beneath it, like that. And if it's not, what I expect, instead of seeing that pouring line of these things come down, I expect that pouring line to be shorter. So just as a quick test before we refresh this, let's save this, but as a quick test, keep your eyes on the CodeRushed drone right over there. We'll toss the, whoops, that's not what I wanted to do. What am I hitting? Did I change the code? I did. Let's undo it. Okay, so let's toss that away like that. Let's move left right now, and let's watch how long. So if I'm starting right about there and I move left, let's change it to 6 actually. And so we'll go flying right underneath it. Watch how long the stream is, and let's see if it changes. So that stream, it spans almost all the way to the top. Here comes another one, interesting. So it spans all the way almost to the top. Now let's refresh. So we're going to come in here. We're going to change our scene selection. That'll refresh our overlay. And we'll get a drone out once that, let's bring up, let's get the drone out first. Just waiting for the overlay to finish loading. There it is. And let's go down. Let's go down 4 and over to the right 7. And this looks like I'm going to bounce. So let's go down 4 again. Try to combat that a little bit. Oh, I'm just all over the place here. Hold on. Try again. Let's go right 3 and down 2. Any better? That's a little bit better. That's getting right about where I want it to be. Okay, cool. And now let's bring out the portal, which is our test sample 4, puts that portal right there. And then we're going to do that same thing again where I'm going to say left 6, and let's see if it's a shorter drop of these, if there are fewer of these. Oh, that's way fewer. That's excellent. That may have actually solved the second problem, which I was going to look for, which is don't drop it. Let's go try and see if we can catch it, though. It didn't seem to have missed it. What is wrong here? Yeah, that one I have to kind of go slow. Well, but it says, so if you add property dropped to meteor drop and then only remove from the list if dropped or caught or exploded, wouldn't that take care of all of the cases? Only remove it. Oh, yeah, I guess I could do that as well. I was thinking about creating a second list is what I was going to do. But I want to see, I was thinking about creating a second list for when it's dropped. And then in that second list, I was going to pull things out of it. But you're right. I could, the meteors to drop, I could mess with that a little bit. Add the property to this meteor drop class right here. And then we would have to come back and find it though later is the problem. And so what I really think I want to do instead, well, actually, I don't know instead what I want to do, but I was thinking about, it was clear while I was sleeping what I wanted to do, but now that I'm awake and I didn't get as much sleep last night as I wanted to, it is less clear. So I'm a little bit foggy and fighting through it a little bit. Not my favorite way to code, by the way. So, all right, so let's see here. We've got, I guess there's a couple problems here. One is I seem to be catching late, it seems to be throwing later, whereas before it wasn't, I wasn't having this problem at all. What I did want to be here. Let's go over here and, let's go, right 5 again. Actually, I want to toss this before I do anything. So I'm going to toss this up like that. Get out of the way. Oops, that was not good. Let's try again. Let's toss it to -4, 8, 9 gets away from me. Let's move to the right, 5. See if I can, what's happening here. So that worked, but it is feeling a little late. Let me drop down a bit on here. Trying to figure out why our calculations are wrong. Let's throw this negative, or they seem wrong here. Let's get that away from me. That was really interesting. Why did that come down on the throw? That was really weird. Let's go left 5 from here. And am I going to slip right underneath it? Yeah. It's like about a half a second off is what it is. And I think I want to fix it by tweaking it, I think is what I want to do. Let's see here. Let's go switch to Pluto. And let's move to the right here, 5. See what happens. That seems like it was totally wrong in terms of the time. Totally, totally wrong. So maybe we've got some other errors here with regards to our calculation. The future drop time is greater than now, then we're good to go. We put it on there. Wait, what's happening here? Oh, I see. Looks like I changed something there with IntelliSense maybe. Okay. Yeah, it's looking like, let's check to see. There's our drop time right there. I think we're going to need to set some breakpoints is what I think we're going to need to do to solve this a little bit. Let me launch the rocket. And I'm not sure why that just dropped right there. I think what I want to do is set a breakpoint here. Looks like, wait, we're not synced up here. Hold on a second, because I've made some changes to the code since I started running. So let's actually instead close down, because I want to be able to break into this. I'm going to set a breakpoint right here. I am going to shut down my Chrome. Saw your command to Mr. Announcer Bot set a breakpoint, but I wonder if I shut it down just as you were trying to do that. That's why we didn't see Mr. Announcer Bot. Let's go ahead and start it up again. Sorry about that. And here we go. I wanted to refresh. All right. And actually, we can just kind of play over here for a little bit. Let's do this. And we'll play on this in this space right here. So we'll do a launch. Let's change the planet to Pluto, like that. So the planet is Pluto. You can see it right there. There's Pluto. Let's do test sample 4. There's our, right there is our portal. Launch a drone. I think I've got the breakpoint set. Looks like I've got the breakpoint set. Look at that already. So we've got this kind of coming right out here in terms of its future drop time. So that's where we cue it, right here. And trying to think of the best way to debug this piece right here. I think this may not actually be where I want to do. Well, let's go see what the drop time is in milliseconds. So that's 8,000 milliseconds, which means it's a drop time of about 8 seconds, which feels right to me. The drop time milliseconds is that. The future drop time is 67. So this also feels, what's now here? Now is 43. This actually, these numbers feel not bad to me. I'm going to just run it here and see what happens. And I don't see my drone. What happened to my drone? Maybe the draw time in the middle of the, maybe draw the time in the middle of the portal should be okay if testing with one drone. Yeah, I have mixed feelings on using the UI to debug, but I'm not opposed to it at all right now. Throughout my years of programming, I've had access to other tools, and so I've been like, oh, these tools are awesome, use these instead. But now I don't have access to those tools, so yeah, I might be doing that, drawing on there. The drop time. Let's look at, I want to see what happened to my drone. Not sure what happened to it. All right, it doesn't seem to be clear what's going on with it. Let's go right 4 here and see what happens. And down a little bit. So, interesting. Yeah, it seems to be off. Left. Let's go left 4. Way off. What is wrong with our calculation? If we go to Earth, everything seems to be fine, right? Or it's off by much less. Let's do that. Let's say right 6. So it's working on Earth, but it's not working on other planets. What if we switch to the sun? Is that crazy? Let's toss this away. All right, and now let's move left 5 and see what happens on the sun. The sun, it works. All right, so it seems like the lower the gravity is, the more the problems we have here. Let's try again. Let's toss this away. Let's change, oh, it's about to get another one here. Boom, okay. Let's change the gravity to, say, Mars, for example. And it's going to drop another one. Or no, it didn't drop another one. That's weird. Let's toss 4,4, get rid of it. And so let's go right 5 and see if it catches it on Mars. Oh, now yep, no, it's not. So we're having a problem with our gravity. It's as if our calculation for get drop time isn't right. And I'm wondering if the distance to drop is maybe part of the problem. I'm saying, I wonder if this is it, right here. I wonder if, because I'm subtracting this dot y plus the portal size, that's that y position right there, future point y. Yeah, I think this might be part of the problem because I want to go from from center to center. It could be the difference in just the falling of that portal size, and that might explain why we're off. Let's change that. Let's refresh up here. And we'll say, let's do test sample 4. There it is. Let's send out a drone. Let's do a launch so we can see the planet. Planets are only drawn if we've launched the rocket. And then let's change the planet to the moon. Okay, so we've got low gravity. Let's also drop down because we want it to be farther away because that's really testing it. And now let's move to the right 5 and see what happens. It did not even launch it, I think, because we were too far away. I think. That doesn't count. Okay, so let's get out from, there's no way we can catch it from here because I'm going to get out from underneath it, I think. Yeah, that feels wrong to me that it dropped it out. Let's start from here. Let's do a right of 7, so we've just got a constant velocity all the way across. What are we doing? Nope. Not going to work. let's do a couple things here. I'm going with your idea, Will, and I like it, and I think I want to, I think what I want to do is, I want to draw the target location, and so that's what I want to do. So Portal is a descendant of Sprite Proxy. That means we can override Sprite Proxy's draw adornments function here. Draw AD adornments. There it is right there. Let's go grab it here. Just copy that. We'll grab draw adornments there. We're going to come over to Portal, and now we're going to use draw adornments to draw the additional pieces that we want to draw here. So what I think we want to do, so the meteors to drop is going to be the derivative type meteor drop, which is the drop time for the meteors. Right? It's got the drop time and the owner. I think what I would do, but I don't think necessarily, we can show the drop time on there, but I don't think that's going to be that helpful because we're kind of already seeing it. What I think I really want to do is I want to do, I could, let's see here, hold on a second. Future drop time. Get future point. I think what I want to do is this for debugging. So it's a little weird, but I'm going to do it for now for debugging purposes. I'm going to do a meteor drop, and I'm going to also pass into it a public future point. Like this. That's what I'm going to do. Future point. Like this. And now, this is just for debugging purposes for right now. So then now what I can do is our meteor drops, I now have all the future points inside of there. Okay, and so what I can do now is, okay, let's pass in the future point right here. Like that. There's our future point. And now what we can do is we can iterate through our meteors to drop. Okay. So something like this. Where's my draw adornment? It's there. It is right there. Okay. So now I want to go through and I want to say, I think don't I have a draw crosshairs? And it's going to take a X and a Y. So pass in the context. And the X is going to be meteors to drop of I dot future point dot X comma this whole thing a Y. So what we could really do is just this. We could say we want a future point here. Like that. And then we're going to come in here and say future point dot X and future point dot Y. It's going to give me crosshairs over all the dropping points that were essentially all the catching dropping points that we're expecting to happen once they're out there. Now, this is going to happen once the meteor to drop is removed, which might happen as soon as it drops. When is that going to come out of there? We splice here. And we splice on drop. So now this is kind of comes back. Hold on, maybe it's a pixel per meter problem with this y, this dot y2. Let's double check that. Let's double check that suggestion. See if we've got that. My sense is no, because it's working seems to work on higher gravity than Earth, and so I think it's a small issue right here with regards to it. Let's see if we can find out right here. So distance to drop, this is in pixels, that's in pixels right there. The distance to drop here is in pixels, but I'm going to call pixels to meters on it here. So we've got that conversion there. This is really where that Y and X are used in terms of what we need to do in there. Get future point, if we look at get future point, we're passing in an X, and that X gives me a delta X, and in that delta X, we're going to call pixels to meters on that too. So we're good here with that one. So I think we're good based on these checks that I've done right here in terms of what we need to do. So now what I'm thinking is we might consider what Will was suggesting earlier, where he's saying, let's take the meteors to drop and not remove them until they are either caught or they've exploded. And I'm thinking about doing that, is what I'm thinking about doing. So yeah, I'm kind of playing with that right now. Let's do it. So meteor drop, let's add a new function here, or I'm sorry, a property here called dropped. That's going to default to false, like that. And then we're going to say, whoops, it's just right up here, I think. If not meteor drop dot dropped, then drop it, and let's also set the this to true. ST will set whatever's on the clipboard to true. It's a CodeRushed template there. So I just had this on the clipboard. I typed in ST and spacebar. Okay, so so there we've set it to true. So we're only going to drop in this case. Then the next question is, we need, so let's maybe look at one more thing too. Maybe we can do this, expected lifetime. So the future point, the drop time and the future point combined should that's the future time right there, and the future point dot let's see, future point, the time, the drop time is there. So the drop time, okay, we can calculate expected lifetime inside of here based on essentially these two numbers. Then the expected lifetime is essentially the drop time MS. What I could do to make this a little simpler, all right, let's do this. I think the code is going to look like this inside a Meteor drop. I think we're going to say something like expected lifetime, no wait, expected catch time equals, no. Let's do say drop time, like that. Drop time is equal to, drop time minus, I believe this, like that. Is that right? I think that's right. Drop time minus future time. Let me just double check because I actually had the secret. So the piece I'm passing in for drop time is drop time minus the time dot m milliseconds minus this. That's what drop time is. That's drop time. And I want to subtract from that future point dot ms, which means I'm going to get to a negative drop time ms is what I'm going to get to. So I think what I need to do is then take the negative of that, which means I need this. I need it to be future time ms minus drop time. Is what's going to should be giving me an expected drop time like that. And let's come in here and put this here like that. So we've got an expected drop time. And now what I think we can do is now check to see if we're past the time of when we want it to land. And actually, I think I'm going to rename this to the landing time, or maybe instead of expected, change it to beyond. So let's just give it some extra life here. So we'll say it's equal to this 3 times that, I think. Like that is what I'm going to do. Nope, nope, nope. Let's just do this instead. Let's just give it a drop time plus 5,000 seconds, 5 seconds. So we're going to say the beyond land time is that. This is all for the purposes of debugging. So now inside of draw, not quite yet in draw dormants, I want to fix the cleanup part where we have the splice. And so now what I want to do is I want to say, well, wait, if meteor drop dot beyond land time minus now is less than 0, then I can splice it and get rid of it like that. So I think that is going to keep this around for a while. And now I can go up in my draw, hold on, in my draw adornments. Now, just double checking this code, I think we're okay. So now we should see crosshairs if we try this and refresh it. Let's see what happens if we refresh it. Okay. It's drawn. Let's do a launch. Let's change the planet to the moon. Let's throw out a drone. And, oh, interesting. Look at that. Now, these should go away, shouldn't they? Why aren't the crosshairs going away? Is my new question. If the crosshairs aren't going away, that means the meters to drop still exist. It means we might have code that's problematic here. Meter to drop time at minus now. Yeah, that's just going to get smaller and smaller as time moves forward. If we haven't dropped the meter, then we drop it. We said it's true. And then we check if the beyond land time minus now is less than 0. Beyond land time was calculated as, oh, it's the drop time, not the land time. Hold on. This beyond land time, I think, needs to be future point dot time plus 5 seconds is what I think this needs to be. I think that might be part of the problem, although I don't quite understand why the why those are not being drawn up. Looks like that was too fast. Okay. still no change. They're still drawing. Okay. Well, I think we're going to have to debug the drawing. Why are these drawing right here? Let's just actually, before we debug it, let's see what happens if I move to the right 4 and down 3 like this. Well, it got the crossing. You can see it's getting the crossing because it's putting those pieces up. It's also clearly not. Oh, it just, boom, there we go. It is cleaning these up at some point. There's the 5 seconds right there. No, but then it brings them all back. Its calculation seems to be pretty good with regards to where it thinks it's going to be. But it does seem like it's not removing these things. The meteors is what it looks like it's not doing. So I think we need to debug that and take a look at that. So to do that, I'm going to have to close this down. We're going to kill off my instances of Chrome so we can restart it. There goes Chrome. And let's, I think, run. All right, so let's figure out what's going on. Why aren't we removing the meteors? I don't get this part right here. The beyond land time is the future point time in milliseconds plus 5,000 milliseconds. Let's set a breakpoint, I suppose, right here. And come back over here. Test sample 4. There it is. Launch. Moon. Drone. Okay, really interesting, as I would expect by now that we would get to a breakpoint. So we're not, because we're not dropping any meteors. Maybe that's my problem. The drop time is being adjusted, maybe. The beyond land time, meteors to drop time. Well, let's go stop. Let's do the breakpoint and draw dormants and see what we've got. So we have 1 meteor to drop in here. The drop time is, what is that? Looks like about 20 million? 20 million seconds from the future. Now we are at only 80,000. So basically what we've done is we've said this is so far in the future that we've put this out here. We've only got 1 though. So it's interesting to me, and we only have 1 portal. So I don't understand why we have so many different crosshairs that we're drawing on here. I don't get that. Right? Because we've got a whole stack of crosshairs here. Let's just see what we've got here. Meters to drop, only 1. 1216, 250. That's our X and Y. Again, what do we got here? 1216, 250. That's my X and Y. Again, running. I'm just hitting a run. 1216, 250. Yeah, I'm totally not. Whoops, what happened? Is it because we're in a breakpoint and it's not refreshing? Let's run it again. No, we got a whole bunch of these. So 1216 and 250 feels like it's this one right here. I'm totally confused as to why these other crosshairs are showing up anywhere else out here. We are literally only calling it from portal right here in this function. Yeah, I'm not getting this at all. Let's try this. Let's do a console log. Send out y, x and y to it. And let's do this, that, comma, that, plus that, like that, future point, x, y. Let's refresh over here. Inspect, bring up the console. Aren't you removing and re-adding Meteor Drop? Let's take a look at that. I think I might be, but I still, if I'm breaking on this, I'm expecting it to show up there. But with regards to QMeteor, I'm pulling it out here and I'm re-adding it here is what's happening. But I'm still expecting to get some numbers that are different over here is what I'm expecting to get. Why is it? I'm just looking to see what... all right, we'll look at that later. Okay, so let's try this out. Let's bring up this, and we'll say test sample 4. Where am I typing? What window has focus? It's clearly not my chat window. It was that one, I see, okay. All right, one over here. Test sample 4. Drone. Okay, hold on. The future point, seconds to crossover, and then future point. Yeah. So if we look over here, right, ultimately it settles down and I stop moving, and we no longer have seconds to crossover. By the way, if seconds to crossover is really big, we should just be like, yeah, we're out and done. But here's our future point right here, right? And it's saying it's 12:16:103. That future point console message is coming out here. So there's only one crosshairs that should ever be drawn. And yet, inexplicably, we've got a whole bunch of crosshairs here. Which I don't get at all. It's really, really bizarre. The whole fact that I'm seeing everything move means that we're refreshing and clearing the context before every draw. So that doesn't make sense to me that we're seeing these. These should all be totally gone away. I don't get that at all. At all, at all, at all. So let's maybe do at least a couple more checks on this though. If the drop time milliseconds, let's do a test here. Let's say if drop time milliseconds is less than, say 10,000, less than 10 seconds from now, if it's going to take more than 10 seconds, we won't do it. Or maybe let's say 20. If it's more than 20 seconds, we won't drop. And then we'll do this and that. And so now we'll kind of work our way in like that. So we've got to have at least a 20-second drop or less. Let's hit continue. Let's refresh. Well, then it says, so that wouldn't that cause a different time to be added, which would explain the multiple crosshairs? The multiple crosshairs are a flippin' mystery to me at this point. Almost as if it hasn't reloaded my changes. Ding, I bet that's totally it. Because, well, no, wait, because I am seeing future point here. But I only draw crosshairs after I call future point, and I'm drawing it with the same coordinates here and here. So there's no other explanation for those other crosshairs. They should not be there. They should absolutely not be there. And we look over in main, I'm sure somewhere in here there's a clear rect call. I'm recalling what it is. There it is, right there at the very beginning of update screen. So we are clearing the rectangle, the entire rectangle every time. So yeah, it's kind of a mystery to me. I guess I can come in here and let's empty cache or do a hard reload at least. Let's try that. Every once in a while we kind of get into this bizarre place here. And we not loaded? Oh, we're not finished loading yet. So we're waiting on that X in the upper left to change. When I do a hard reload, it goes through and reloads, I guess, everything. So it always seems to take longer, much longer. Okay, there it is. Here's our test sample 4. Now let's launch our drone. So we're still seeing a bunch of things, and then it should stop at some point. I feel like it should stop because we're more than 20 seconds away. Oh, you know what? I'm checking on the wrong piece, I think. It's not the drop that I care about. It's the future time is what I'm caring about. Hold on. It was here in Portal. This is wrong. It's not this. It's this. If the future drop time is greater than now, let's just do it this way instead. If future drop time is greater than now and future drop time minus now is less than 20,000. That's, I think, what we're looking for right there. If it's less than 20 seconds, fair enough. I'll just change it to 10 because I think 10 is reasonable. Even on Pluto, I think 10 seconds is enough time for it to drop. And let's try that. Let's do a refresh over here. And we're good. Here comes test sample 4. And drone, launch. Oh, look, we're not seeing them where we had seen them before. So let's move down, and then let's move to the right. Are we going to see anything? Seconds to crossover. So there you can see, cool. You can see the numbers coming up over here. So it's telling me how much time is coming up. And so seconds to crossover, we're past 20 seconds and we're like, yeah, we're done. So let's move over to the right. Got one that showed up, and then we're kind of cranking it up again here. Let's move to the right again. Let's move up and move right. Okay. We're clearly not erasing these. I'm going crazy. How is this possible? Yeah, the future point, is it always the same? 1216, 334, 1216, 334. It should always be drawn in the same spot all the way up. 1216, 334. There's the splice call right there. You can see it right at the bottom here. So when the splice call came in, that's when we stopped seeing all of those crosshairs. What's going on? Wait a second. I think I might have an idea as to what's going on. It has nothing to do with our code. It has to do with the way that we are drawing the crosshairs. I think we're creating and adding to I think it has to do with, I think there's like an open path and closed path is what I think might be happening. And I think what's happening is we're adding more of these pieces right in here, even though this stroke call is here. So I think what's happening is we're adding them all to it. So, and because they're lines, they're just kept and held between each one. This would explain why they're not being cleaned up. So let's go take a look at JavaScript line drawing, JS line draw with context. Line 2 method. There we go, begin path. I bet we need that. That's our missing piece. And I'm not sure if there's an end path. Let's see if there is, because if there is, we'll throw that out there too. Just a nice clean that up. Looks like we don't. Looks like we just need something to say this is the start. I bet that solves our multiple line draw problems. If that works, I'm going to be very happy about that. And I bet it does. That's also kind of an interesting learning path. Yeah, Will Bennett confirms. He says context.begin path. Yes. So let's take a look at that. Let's say test portal. Oh, no, sorry, not portal. Test sample for. There it is. Drone. And let's move right 5 and down 3. There we go. Look at that. That's what I wanted to see. Boom. Okay, so we're calculating the crossover point correctly. We absolutely are. The next thing we need to check to see is our distance between those 2 points correctly calculated as well. So let's take a look at that. That's weird. I don't understand that. Why that meteor just dropped there. I didn't get that. But let's go here to the left again. Let's go left 4 and up. Oh, it didn't change the position as I moved up. Let's try again. Let's go right 5 and down 4. There we go. Look at that. Look at that. Is it going to hit it? Pretty close. It's pretty close to it. Okay, let's close down this. And there was a ghost drone, Will Bennett says. I did not see that. I'm looking over at the stream right now. There. That's weird. Right there, that piece. You think there's another drone on there? I'm not sure. But let's go over to let's go left 3, 4, and maybe up just 1. Yeah. So that's pretty good. And so let's go down. And let's go right. And keep going right. So that was weird. We didn't get anything there. Left, 3. There it is. There it sees the crossover. Boom. So there I caught it because I was slowing down, I think. I think that normally I would not get that. Toss. That. Let's go down 3. Let's go down 2. And right 4. Yeah. So we're getting it. The drop time's not calculated correctly. It's off by some amount. Let's figure out if our distance that we believe it is actually equal to the distance that it is. Let's see if we can take a look at that. See if that's I think the next thing I want to look at. So with regards to our future points, now we don't need this anymore, I think. We can just do the future point there. Q meteor. So when we call this the meteor drop, the meteor drop is, I think I also want it now to hold additional information like, well, the future point is X and Y. Distance to drop. This dot plus portal size divided by 2. That's our Y position in the center here. And our future Y is the center. That distance to drop should be correct looking at this code. It feels right to me. I'm looking at this line of code right here. The call to get drop time is basing it on the current gravity. We're multiplying it by 1,000 to convert it to seconds. Wait. Get drop time. This says milliseconds, but these are seconds. Hold on. Is that my problem? That I'm simply wait, times 1,000. Oh no, wait, this is in seconds. That turns it to milliseconds. That's correct. Sorry. Okay. And then my future drop time is the future time. That's our expected time that it thinks it's going to cross it, minus our time that we think we're going to cross or our time to drop. Is essentially what it is. So either we're calculating the future time well, let's maybe do this. Let's put down our time when we think we're going to cross it and see if it matches when we actually cross it. So let's do that and draw adornments right here. So here's this. Then the next thing I want to do is something like this. Context dot, what is it? Draw string? No, string. Is it text? Must be text. Text align, stroke text. Fill text is what I want. Fill text. And the text I want to fill is here. And I'm not sure what that's going to be yet. The X is going to be pretty close to that place right there. And what I want is the time to be here. Let's do this also. Let's say fill style is equal to, I guess I'll just put black for now. And the text is going to be my future point dot time milliseconds minus, now minus the future time milliseconds, I think. Is that right? As a string. And I think that that'll get us something. That's going to get us something in there. All right, so let's give that a shot. Give us some text nearby there. Do a refresh over here. See what happens. I think we're going to see negative numbers, and we might want to tweak this a little bit, but we'll see. Test sample 4 and drone. If you press open paren with a selection, it should embed in parens. Really? That's CodeRushed feature. Is that a Visual Studio feature is now as well? Yeah, I think it's a CodeRushed feature you're talking about. And I think it's not enabled yet in inside of CodeRushed with TypeScript files. I think it's something I don't have enabled yet. All right, so let's go here and try this out here. Let's go down 3. Whoops, where am I typing? I'm not sure. Over here. Down 3 and right 6. Let's see what happens. Where is our plus? There it is. So it's negative, negative, negative. And then, yeah, so it's interesting. It's kind of going the opposite direction where I'm expecting it to be. So it's time, milliseconds minus now. Yeah, that's right. I wanted to do that minus this. I also want to just turn it into, I think, seconds. And so let's just create a new number here. Let's see, seconds to drop. And we're going to say that's equal to, and it's going to be equal to this. that. And it's going to be this. That's in milliseconds. So divide by 1,000 will give me my seconds to drop. And I think the other thing is I want to round it. And so what I want to say is math.round, like that. This piece right there. And let's try that and refresh it. See if we get something a little clearer. It works for me. Interesting. And that's in TypeScript, Will. Maybe I've got the option turned off. Let's go see if that's the case. Options. I thought we hadn't added it yet. I have no selection embeddings here that are declared. And it's also in shortcuts as well. Shortcuts. And let's get there. And embed. Here's the parentheses right here. So, and it's calling the command embed parentheses. And I don't see any context on it. Let's see, let's double check. Make sure the context. Yeah, it looks like it should work for me, but it's not. It's not working for me. So I assumed we had not ported it over to TypeScript yet. I'll talk to the devs about that after the show and see what's going on with that. Okay, you can do number.toFixed. What is that? That's the number of decimal places? Is that what that is? That looks awesome if that's the case. So instead of calling round, cool. Let's look at that. Whoops. Need to get this whole thing in parens right there. ToFixed. Beautiful. Fraction digits. 2. I did not know that existed. I actually looked for how to do this before, and they were saying to do it to a certain number of decimal places, multiply it by 1,000, round it, and then divide by 1,000, and then you'll get your decimal places to 3 decimal points or something like that. Seconds to drop. ToFix, is that a string? Yep, it returns a string. All right. Let's do this. Whenever I have a string, I like to do just kind of indicate it like that if it's not obvious, if otherwise it looks like a number. So I'll put in the stir at the end. Let's refresh out here again. There's the sample. Let's bring out the drone. And let's go down 3 and right 5. Okay, let's go left 4. Looked like the time was right on the cross. Let's go down a little bit more. Let's go right 4. 1, 0, boom. Yeah, it looks like it is. It looks like it's there. We could do one other thing to kind of make it super obvious. We can do this. We can say, let's say seconds to drop. Let's go back and make this a number. And before we go to ToFixed on it, like that. Like that. And I want to check to see, I want to do this. I want to say, hey, look, if seconds to drop is less than 0, that means we've dropped it already. Otherwise, we're going to do this right here. So we're going to do something different is what I want to do here to just make it very visually, obvious what's happening here. So I want to say context dot, not fill text, but do I have a fill rect? And I want to say, I want to create a rectangle around this. It's nice and big that I can see. And we're going to come in here and say the fill text is equal to just totally red like that. Maybe orange, so that means we need a little bit of green over here. So something like this to maybe get us a green, an orange. And so here for the fill rect, it's going to take X, Y, okay. And so we're going to come in here and we're going to say rect size like this. Let's make it 100. And so we're going to say this minus rect size divided by 2, and that minus rect size divided by 2. You can do, oops, sorry, I thought I saw Will saying something new. Okay, there we go. So there's our fill rect call. Let's refresh it. So we're looking for that big splash of the rectangle. You can probably just change the font size much easier. Oh, interesting. Oh, well, we should probably do the font size change anyway, is what we should probably do. Let's do this. Context.font. Is there a family in here? There's a font size, font fit. I thought we had a font family. What was it? Just say, you think it's just that? Font equals 20 pics like this? That doesn't make sense to me. I think there's an actual property. I'm looking for the property in here. PX, Arial. I'm forgetting this. We've sent text out before, but we are, let's do this. Let's see if I can find that example code in my own. Font is equal to, yeah, that's it. It's just straight out. We can assign it to a string like that. Okay. Surprising and cool. All right, so let's do that and refresh one more time. And let's say, bring out the drone, bring out the test sample. There it is. Let's go down 3. Let's go right. 5. Let's wait till let's just do that. So I should see. So that's interesting. It seems like we're so far out. Now there we go. So there. Now that's cool. So we're seeing what the hit time is on it there based on the speed. Now it's dropping down. So this is interesting. This explains this one. That was super interesting. So what happens is we start slowing down, but we don't take it off. And so I think the thing is, why aren't we taking it off? Because it's too big. Hold on. I think I know why that extra one's coming out. So the extra one is coming out. It has to do with this piece right here. So I think what we want to do is this. I think what we're going to do is say this. Look, if the future time is less than 10 seconds away, do this. Otherwise, we want to remove from that, we want to do something like remove Meteor. This is the slowdown piece right here. This is going to stop that second one from coming out. And we want to pass in drone.userID. We want to pull that Meteor out is what we want to do. And let's go take a look at QMeter right here. And let's go see if I could reuse some code here, but I don't think I'm going to be able to do that because this is comparing with the owner of itself. This, I want to have a user ID coming in here. Like that. And I could make sure there were not multiples in there, I suppose. All right, so I think that's going to save the second one from coming down. Let's refresh again. Here comes test sample 4. There's the drone. Let's move down. Let's move right by about 5. There it is. 2, 1, 0. Okay, well, that certainly seemed to work. Let's change to Pluto, because that's got very low gravity. Let's toss this away, and let's move down a bit, maybe down a little bit more, move to the right a bit, kind of get a nice little running start. And now let's go left for maybe 9 seconds and see what happens. 5, 4, 3. Oh, interesting. The collision time is way off. It has to do with our expected cross time over it is way off. Let's try again. Left 4. Three, 2, 1, 0. Boom. The countdown for the it's the countdown for the drone that's there, but I'm not seeing the countdown for the for our crossover. It sounds like our crossover collision time is not right, is what it looks like to me. The future point Y has a time in milliseconds as well. So let's look at our draw adornments. Yeah, our future point time in milliseconds seems to be incorrectly calculated, is what it's looking like to me. And that's inside of get future point. Let's look at this one more time. Get future point. Seconds to crossover. I think this might have something to do with it right here. Wait, no, meters per pixels. No, this isn't pixels. Sorry. I have to look very carefully at this code. Okay, so now plus seconds to crossover. Because the other code is counting it down and getting there. It's their drone is getting there much faster. So the seconds to crossover, basically the problem is I think in this line of code right here, let's just double check this. Seconds to crossover is also used to calculate the Y at the crossover. And when I'm drawing in the portal, hold on a sec. In the draw adornments, my crosshairs are going on the future points Y, right? So that's the case there. So why are the seconds to crossover so far off? So it either means velocity x is wrong, or it means this equation is wrong, is essentially what's happening there. I'm going to trust that the velocity x is, I'm going to assume that velocity x is not wrong. So velocity x is in meters per second. We're dividing by meters per second. We have meters on the top. Meters cancel out, and because we're dividing by something per second, the seconds go up on the top. So that unit is in seconds. It absolutely should be in seconds. Pixels to meters. That looks good. And yet, if we come out of here, let's change our planet here. I bet you wish Rory was here, says, well, yeah, I do actually. Would love to have Rory here. Absolutely. Yeah. So that time there, that's not getting it. Let me come over. Let's come over here, set a breakpoint in here. See if we can get something decent. Get future point. Problem is, we're going to do this on every single one here. Let's just do this. Come in here and inspect. Seconds to cross over are here. I'm right underneath it. Is it an acceleration problem? I don't think so. I don't think so, because we're kind of updating it as we kind of go through. It might be that it's dropped it, but I think if I move, let me move left like 5 to get out of over here. Like there, it shouldn't have dropped at all. It should have known that it was going to miss it. And let's move right 5. Hold on. Let's go to the left again. I'm watching these numbers right over here on my shoulder. Let's go over left again. Let's go over here. And I want to just, what's interesting to me, okay. So now you can see the seconds to cross over kind of scrolling up right over here. And let's move right 5. So okay. So this thing popped up when the seconds to crossover was at about a 6. I was watching this and I was like, oh, I saw it popped down to be right about a 6, right around in here. In fact, you can see, look, we're pushing meters, and there's the last one we push right there. And at that point, it feels like it's going to be 6. And at that point, this calculation might be right because it could actually have something to do with acceleration. And we don't push anything after that. So it could be that this code is correct, but that in Portal, our code to basically see what's going, whether we should drop or not. In other words, this code, future drop time, is maybe problematic. Future drop time milliseconds, time ms, is when we're going to cross, minus that. This means we can't get to it. I think we need this as well. We need another version of this underneath that, is what I think. Or maybe a better way to do it is something like this. And this, then that. But I feel like I should, be very clear that I'm getting the feeling I'm grasping at straws right now. That I am, what's happening is hard to visualize, and I'm not sure how to, if this is going to fix it or not. But I'm playing basically. I'm exploring and trying to understand. All right, so let's see. Test sample 4. Launch. Right like that. Drone. Right like that. Right 5. Down 2. Oops, I didn't say down 2. Okay, let's go left 5. Is nothing happening now? Not dropping anything? Interesting. All right, so let's go down, right. Oops, I'm hitting 4. I meant to say right. Yeah, it's going away. What do we do? Okay, let's undo this, get back. So that also means that this removing the meteor is not going to make sense here either. Okay, let's restore it, watch it, just make sure we're back to normal. Okay. Yeah, it's I'm not quite figuring it out. It's as if we've kind of got one queued up and we're not replacing it. And we could replace it, I guess, is the thing. Yeah, it really seems to be that our calculation to that crossover point is incorrect, is what it seems to be. Q meteor. Let's go look at Q meteor a second here. Yeah, we're taking the existing owner out of that and removing it. So if the meteor's already there, we are removing it and adding a new one out there. Let's look at look at our messages in the inspect window again, console log. Okay. So meteors.splice means we're removing the meteor. So here's the push. We push here we push. And we push to here at 1.8 seconds about. And then after that, we count down the crossover. So let's go look at the push again. There's the push right there in Q meteor. And we've just gotten the get future point. All right, so let's do this. Let's let's start putting some more stuff in here. So we've got seconds to crossover up here. We're going to put our final velocity x as well. Put our delta x, I suppose. And our velocity x. So we've got that, and let's put in seconds of crossover here as well. We'll put this whole thing down on the next line here. Like that. So now just send out more data, see if that's going to help us, give us any insight. Interesting, got all the way across. There's something there. Let's go left. All right, hold on. All right. I wonder if you do the test high, does it work? Maybe it only fails when the drone is too low. Yes, it does work when it's higher. When I'm up higher, there's not a problem. It's the further away I get, the greater the error. So let's try this again. Let's go like right 4, like this. I'm expecting to catch, like that. And it is further down that it fails. Here, let me close a second, just to demonstrate that, so you can see that. Also, it has to do with the. Let's go down 3, and go left 4. Let's go down again, down. There's the moon. So here's where you can really see the problem. If I'm down low, like that. So left 4, there it is. What is going on? Yeah, unfortunately, my brain is not clear enough, I think, to see this right now. I have a feeling that, sometimes this happens, and I think that it's probably best that that we call it a show, and tomorrow, or actually Tuesday, come back in, or whenever I have a more alert brain, come back in here, and we try to figure out what's going on. That's my sense. It definitely is something unusual about getting the future point and this time right here with regards to it, because when I come back into Portal and I've got my future point, I've got my time milliseconds, my future drop time is here, and my future drop time is coming out to oh, interesting. This is copied here and here. We can simplify this by just saying there's my future drop time, like that. And if I go into Meteor Drop there, that maps out to the drop time property, which we can probably rename this to future drop time now, so we're a little bit more consistent. And and then go back over to our draw adornments. Whoops, over in Portal, sorry. Draw adornments, I'm calculating the seconds to drop is future point dot time dot ms, which it should be. This is the time. This should be the time to intersect, is what it should be. The future drop time is something completely different. We can do this. We can just come in here and say let future drop time. We can put both of these in here. Is equal to the future drop time. So that's, put that out there just to see. Maybe I made a mistake in the, with regards to conflating these two, coming up, getting into this situation, but I don't think that's the case. Seconds to drop. This should actually be called seconds to intersect, which is, we know is wrong. Absolutely. And this other one, we need to create something that's like a seconds to drop. Should be using this. Like that. And then we want to think we want something along the lines of if seconds to drop is greater than 0, and if this is the case, let's put this down one, like 24, 30 maybe, 30 pixels down from that. Seconds to drop, and we're going to do this, and then we're going to say seconds to drop, stir. Oh yeah, this is local, so we're okay. And this should be seconds to intersect, stir. Just come in and do this right there. Do the same thing here. So the number on the bottom is going to be the seconds to the drop, and the other one number on top is going to be the seconds to the intersect. Let's see what that data tells us. Times 10 second. Hold on. Will says, then I believe you can't fix that since the portal doesn't control how fast the meteor falls. Well, gravity does. We're using gravity. You have enough time to make the drop. Changing your 10,000 second limit should make it closer. So the limit needs to be increased. The lower you are because the meteor needs extra time. Also explains why it doesn't work in low gravity as well. Yeah, I'm not sure about that. I'm not sure about that. Valiboo says, hello, darling. How are you doing today? Nice beard, though. Doing well. Relatively well. Would be doing a lot better if this was going faster and working like I wanted it to. So let's see if what we get. Whoops, not that. It's test sample 4 and launch. Yeah, I'm a sad panda. There's my launch. And do we not have, it looks like we do not have, really interesting, we do not have Mr. Announcer Bot running now. Is that right? We can't, can we do that? No, we cannot. Interesting. Okay, so let's see. We want to launch a drone and move over to the right by 4. And we have 2 numbers coming in. Look at the 2 different numbers. The one on the bottom is definitely, let me move down a bit. So I'm not in the way here. Down again. And let's go left. 3. Boom. Boom. It's interesting. The bottom number runs out way faster than the top number. The bottom number is this piece right here. This is the bottom number. That's the seconds to drop piece. And I guess that does make sense. That's the total seconds to drop. So that's just telling us when the thing should go. So that actually is not that interesting to us. It's the intersection piece that's more interesting anyway. So yeah, that's not helpful. I'm going to comment that out. And comment this out too as well, I think. Like that. Yeah, so I think we're going to have to, I'm going to have to take a break, recharge my brain, and come back in here and look at this again. So yeah, Sad Panda, disappointed. Sometimes it happens. But, you know, I think the other thing that's nice about having Rory here is he's got a second fresh brain to look at it. So it's doing that pair programming kind of thing. So we will get back into this, I think, on Monday, Tuesday. But knowing me, I'm probably going to be thinking about this and have a moment where I'm like, and I'll come back in and try and fix it. So there may be a surprise stream if I get an aha moment as we're moving along. But I think that's going to be it. We'll call it a show for today. Thanks, everybody. And we will see you at the very least farthest way on Tuesday. Yeah. Will Bennett says you get in trouble with the cops when you are resisting arrest. Very clever. All right, guys, we'll talk to you later. Kids, I just had an idea as I'm watching this. The idea is at the very least to show your velocity on the drones. So not so much maybe to solve this, but at the very least on the path of solving this, show what your velocity is, at least the x velocity, left to right velocity, because that's kind of what we're looking at. We want to get a sense of what that is. And I wonder if also that we should, just trying to think of other ways that we can see what's going on here. Yeah, I know I said I was going to end this, and clearly I'm not. So the bonus session here, but I'm watching this, and I'm just thinking in the draw dormants here. We might do something here where we put in, at the very least we can put in our velocity and do that. Get the future point. Yeah, I'm thinking what I'm going to do. I'm playing with this idea of getting more data out on screen. I think what I'm going to do is maybe save the last future point we calculated and show that on screen where that is. And also maybe show some of the other data, like our velocity at the time we calculated it, and the time to cross over, horizontal thrust, that sort of data. So I think I am going to end the show. I'm looking at this. I am going to end the show, but I'm going to, what I will do is, this is the area that I'm going to be focusing on next time when we come here. So So I guess that's it. We did our fake ending. We'll do our real ending for now. And oh, you know what? I forgot. We also have to give away a copy of CodeRushed. So let's do that part. I was so focused on this code. So let's get into that.
CodeRushed giveaway.
Genescu7 says if it drops the player with the physics on the Calc 2. I'm not sure what you mean on that, Genescu7. Here's the winner. Today's winner.
Vlad Sky Dreamer.
Vlad Sky Dreamer is the winner today. So I will contact you via DM and get you that. Yeah, Genescu7 is for the Meteor. If it drops the player with the physics on the Calc 2, I think you're saying show that calculation is what you're showing it. Yeah, nice throw, Genescu7. Nice throw. All right, kids, we'll see you on Tuesday at the latest, maybe over the weekend if we're lucky.